My name is Eva Vera, and I'll be explaining the derivation of the Michaelis-Menten equation. We start with the enzyme plus the substrate goes to the enzyme-substrate complex. And then this enzyme complex with the substrate goes to the enzyme plus the product. The forward constant is K1 in the first equation, and the backward constant is K to the minus 1. In the second equation, the enzyme substrate complex goes to the enzyme plus the product, and that forward constant is K2. We can eliminate the backward equation because not enough product in the beginning will be able to go back to the enzyme substrate complex. The instantaneous rate of change of the formation of ES, we can write d ES over dt equals constant 1 times the enzyme concentration times the substrate concentration minus K to the negative 1 times the enzyme substrate concentration minus K2 times the enzyme substrate concentration. And this all equals 0 because we're assuming a steady state approximation. The creation of the ES complex is equal to the sum of all reactions decreasing its concentration. So we have K1 times ES concentration minus the K negative 1 times the ES concentration minus K2 times the ES concentration equals 0. Because it's difficult to determine the value of the free enzyme, we need to find a different equation. And we know that the total enzyme concentration equals the enzyme concentration plus the enzyme substrate concentration. And we can solve for E, the enzyme concentration, which will be the concentration of the total enzyme minus the concentration of the enzyme substrate complex. And if we put this definition into our first equation, we will get equals K1 times concentration total minus the concentration substrate enzyme total times the concentration of the substrate minus K ES minus K2 times ES. So we're multiplying this out. We're going to get K1 times the total concentration times, I didn't write, the concentration of S minus K1 times the concentration of the enzyme substrate times the concentration of the substrate minus K negative 1 minus K2. We can rearrange, putting all the product with ES on one side of the equation. And we know that this equation equals 0. So by rearranging it, we get K1 times the enzyme total times the substrate total equals K1 enzyme substrate times the substrate minus K plus K1 backwards plus K2 times the enzyme substrate complex. We can then factor out the enzyme substrate, and we get ES times K1 concentration of substrate plus K negative 1 plus K2. And that equals K1 times the enzyme, total enzyme concentration times the substrate concentration. To isolate the enzyme substrate concentration, we can divide both sides by this value. And that will give us that the enzyme substrate concentration equals K1 times the total concentration of the enzyme times the substrate concentration divided by K1 times the substrate concentration plus K to the negative 1 plus K2. And if we multiply the top and bottom by 1 over K1, which is in effect multiplying by 1, that gives us total concentration of T, of the enzyme, times the concentration of S, all over concentration of S plus K to the negative 1 plus K2 all over K1. And we know that Km equals K to the negative 1 plus K2 over K1, and we can substitute that there. And that will give us the enzyme substrate concentration equals E total enzyme concentration times substrate concentration over the substrate concentration plus the Michaelis constant. We also know that dP dt is the instantaneous rate of change of the product, and that equals to K2 times the enzyme substrate concentration, which we know is that. And we can substitute that into here, and we get that dP over dt equals K2 times the total concentration of the enzyme times the substrate over the substrate concentration plus Km. The rate of the product formation is the velocity, giving us that V equals K cat, which is another name for Ks, times the total concentration of the enzyme times the substrate concentration, all over the substrate concentration plus the Michaelis constant. K cat equals K2, which also equals the turnover number. How many molecules of the enzyme can work with per second? How many molecules the enzyme can work with per second? The total concentration of enzyme times the maximum number of molecules an enzyme can catalyze per second gives us V max. If all the enzyme is reacting with the most molecules possible per second, we have the maximum rate. So that would give us V equals V max times the substrate concentration all over the substrate concentration plus the Michaelis constant, which is the Michaelis-Menten equation. Thank you.